Hello everyone, respected judges and audience. We are Team NeuroCloud and today we are here to present our project, PayShield, Earn, Insure and Stay Protected. Before we begin, I want you to imagine a delivery partner working full day, riding through traffic, heat and long distances. And at the end of the day, their income depends entirely on how many deliveries they complete. Now, imagine the next day, it rains heavily, roads are flooded, orders drop, and movement becomes difficult. That entire day's income gone. Not reduced, not delayed, completely gone. This is the reality of gig workers today. They do not have fixed salaries, they do not have paid leaves, and they do not have protection against external risks. That is exactly where PayShield comes in. PayShield is designed to act as a real-time financial safety net that protects the income of gig workers when they are unable to work due to external disruptions. Let's now move forward and understand the problem in detail. Let's now look at the problem statement more deeply. India's gig economy is one of the fastest growing sectors, especially in logistics and delivery services. Thousands of workers operate daily across platforms like Amazon, Flipkart, and other delivery networks. These workers are not salaried employees. Their income depends entirely on completed tasks, meaning they earn on a per delivery basis. This creates a highly volatile income structure. Now consider the impact of external disruptions. Heavy rainfall reduces road accessibility. Floods block entire zones. Extreme heat reduces working hours. Curfews restrict the movement. Platform outages stop orders completely. In all of these cases, the worker is willing to work but physically cannot. As a result, their income drops instantly. According to the problem statement, this can lead to a 20 to 30% reduction in their income. Now let's examine why existing solutions fail. Traditional insurance systems are not designed for this use case because they require manual claim filling, they involve long verification cycles, they are designed for rare events, not frequent disruptions, and more importantly, they are not aligned with daily or weekly earning patterns. So, even if a worker has insurance, it does not actually help them when they lose income for a day or two. This creates a clear gap, a need for a system that is immediate, automated, and aligned with real world work patterns. Let's now move to the next slide to understand how we solve this. To address this problem, we designed PayShield as a parametric insurance system. The key difference between traditional insurance and parametric insurance is that we do not depend on claims. Instead, payouts are triggered automatically based on the predefined conditions. In PayShield, workers pay a small weekly premium. The system continuously monitors the environmental and platform conditions. When a disruption occurs, payouts are triggered automatically. This means no claim submission, no waiting period, and no manual verification. The system itself detects the problem, validates it, and compensates the worker. Additionally, we integrate AI into multiple layers: pricing optimization, risk prediction, fraud detection, trigger validation. This makes the system intelligent, adaptive, and efficient. Now, let's look at how we structured our plans to accommodate different types of workers. To make PayShield usable across different income groups and risk profiles, we introduced three planned tiers. The first is Safe Start, designed for workers in low risk areas. It has lower premium, limited triggers, and lower payout cap. The second plan is Smart Cover, which provides balanced protection. It includes more triggers, moderate payout limits, and balanced pricing. The third plan is Full Shield, designed for high risk workers. It offers all triggers, higher payout caps, and priority processing. The idea behind these plans is to ensure that workers are not overcharged, risk is fairly distributed, and coverage matches real world exposure. Now, let's move to how pricing actually works behind the scene. Our pricing model is designed to be fair, dynamic, and data driven. We calculate the weekly premium using three factors: base rate times zone risk times worker risk. The base rate is derived from overall claim probability across the system. The zone risk multiplier depends on location specific data such as weather history, flood frequency, and environmental conditions. The worker risk score depends on activity consistency, working hours, and earning pattern. The AI models continuously analyze historical and real time data to adjust these values. This ensures accurate pricing, fair distribution of risk, and long-term sustainability. Now, let's take a look at the GitHub link repository. So in this repository, we have also included the README file of the entire problem statement. Now, let's move to the most critical part, how payouts are triggered. PayShield uses parametric triggers based on objective, real-world data. These include rainfall above 50 millimeters, flood alerts, temperature above 45 degrees, curfews, platform outages. These triggers are chosen because they directly impact a worker's ability to earn. Now, one major challenge in such systems is fraud prevention. For example, a worker might try to switch to a high-risk area after a flood alert to claim benefits. To prevent this, we implemented a GPS-based microlocation system. Workers are assigned to zones before the event occurs. Once the event starts, no zone switching is allowed. Only pre-assigned workers are eligible. This ensures fairness, accuracy, and prevention of misuse. Now let's take a look at the technology behind the system. Taking a closer look at the technology behind PayShield and how we design the system to be both reliable and scalable. While the idea of PayShield focuses on simplicity for the user, the backend system is designed to handle real-time data, automation, and intelligent decision making. Let's start with the front-end layer. We used React along with Tailwind CSS to build a responsive and user-friendly interface. The goal here is to ensure that gig workers who may not be highly tech savvy but can easily register, select plans, view their coverage, and track payouts. The interface is designed to be minimal, fast, and easy to navigate, even on low-end mobile devices. Moving to the backend layer, we use Spring Boot with Java. The backend is responsible for handling business logic, managing user data, processing triggers, and coordinating payouts. Spring Boot was chosen because it provides strong performance, scalability, and secure handling of transactions, which is critical for an insurance-based system. Now coming to the AI layer, which is one of the most important parts of PayShield. We implemented AI services using Python frameworks like Fast API and Flask. This layer is responsible for predicting risk levels, calculating the dynamic premiums, detecting fraudulent behavior, validating triggers using real-world data. For example, the AI model can analyze historical rainfall patterns and predict the likelihood of disruptions in a specific zone, which directly affects the pricing. Next is the database layer. We use MySQL and PostgreSQL to store structured data such as user profiles, payment records, trigger history, payment logs. This ensures that all operations are traceable, consistent, and reliable. Finally, we use cloud services, specifically AWS, including services like Lambda and DynamoDB. The cloud layer allows us to process events in real time, handle large scale data efficiently, scale the system as the number of user grows. Overall, this tech stack ensures that PayShield is fast in response, reliable in operation, and scalable for future growth. And most importantly, capable of handling real time automated insurance workflows without delays. Now that we understand the technology, let's move to how we ensure the system remains secure and fraud resistant. Now, one of the most important aspects of PayShield is how we control payouts to ensure sustainability. We implemented three major mechanisms. First, event-based cooldown. This ensures that one disruption event leads to only one payout sequence. Second, weekly payout cap. This limits the total payout to around 40 to 60% of weekly income. Third and most important, diminishing payout model. Instead of paying the same amount every day, we reduce the payout gradually. Day 1 equals 80%, the second equals 60, third for 40, and fourth for 20. This reflects real world behavior, where workers gradually adapt to disruptions. It also prevents dependency on insurance and ensures financial sustainability. Now let's see how everything works together. Let's now take a step back and understand how the entire PayShield system works from start to finish in a real world scenario. The workflow is designed to be completely automated and seamless for the worker. The first step is worker registration. The worker signs up on the platform, provides basic details, and selects a suitable plan based on their risk level and affordability. Once the plan is selected, the system activates weekly coverage and premium is either deducted or recorded for that cycle. After this, the system enters a continuous monitoring phase. It constantly tracks the weather conditions, the government alerts, platform availability, and zone level disruptions. Now, when a potential disruption occurs, for example, heavy rainfall exceeding the threshold, the system moves to the next stage, which is trigger detection. Once a trigger is detected, the system performs multiple validation checks. It checks whether the worker was assigned to the affected zone before the event. It verifies the GPS location data. It analyzes the worker's activity to confirm income loss. It runs fraud detection algorithms using AI. Only if and all these conditions are satisfied, the system proceeds to the final stage, that is the instant payout. The payout is calculated using the diminishing model and directly transferred to the worker, typically via UPI, ensuring immediate financial support. The most important thing here is that the worker does not need to take any action. There is no claim process. The system itself observes, decides, and pays. This makes the entire experience fast, reliable, and completely frictionless. Now that we understood the workflow, let's look at how this system can scale in the future. Now let's look at the scalability and future potential of PayShield. While our current focus is on delivery workers, the underlying architecture is highly flexible and can be explained in multiple decisions. The first area of expansion is platform integration. By integrating directly with delivery platforms like Amazon or Flipkart, we can improve data accuracy, verify assignments more reliably, and enhance trigger validation. The second area is mobile application development. A dedicated mobile app would allow workers to track their coverage, view payouts, manage plans easily. This would improve accessibility and user experience significantly. The third area is expanding trigger coverage. Currently, we focus on weather and operational disruptions, but in the future, we can include pollution levels, strikes, traffic disruptions, public emergencies. This would make the system more comprehensive. Finally, we can expand beyond delivery workers to other gig sectors such as ride sharing drivers, freelancers, field service workers, and etc. All of these workers face similar income volatility issues. So, PayShield is not just a product, it is a scalable platform that can evolve into a broader financial protection system for the entire gig economy. Now that we've seen its capability, let's move to the real world example to understand how it works in practice. Let's understand everything with a real world example. Consider Rahul, a delivery partner working in Aziznagar. He earns 1000 per day. Now, suppose heavy rainfall occurs for 4 days. Rahul is unable to work during this period. Instead of paying a fixed amount of full compensation, PayShield uses a diminishing payout model. Day 1 800, 2 600, 3 400, and 4 200. Total payout becomes 2000. Now let's analyze this. Rahul lost 4000. He received 2000. This means he is financially supported but still encouraged to return to work. Also, even if this spans across 2 different weeks, it is treated as a single continuous event, preventing duplicate payouts. This makes the system balanced, fair, and sustainable. To conclude, PayShield transforms traditional insurance into a real-time intelligence system. By combining weekly subscription model, AI-driven pricing, parametric triggers, automatic payouts, we create a system that is fast, fair, scalable, and fraud resistant. Most importantly, it ensures that gig workers are protected when they need it the most. PayShield, protecting your income where work stops. You can take a look at our website here. Here you can find the differences between the automatic and the traditional mechanism. Now, let's move on. Thank you for your time and attention. This project was developed by Team NeuroCloud. We appreciate the work opportunity to present our work. Thank you.